Welcome to this video series where we create a Lisp parser from scratch with TypeScript. In the last episode, we finished the arithmetic evaluator. In this episode, we will extend the parser to handle boolean expressions. But first, there's a bit of cleaning up to do. One of the viewers noted that I'm not using the just testing framework to its full effect. Thank you, Canon Tank. So we will go ahead and improve those tests and delete a bunch of code. Simpler the code, easier it is to maintain and to understand. So we've been using .to be call to compare, but there's a better way. .equal call can do a deep comparison on objects. This will reduce the number of comparisons we have to do inside a test. So let's go ahead and make that change. Brilliant. Let's get on with implementing the comparison operations now. And we start with a test. So here we enforce that a comparison operator should have two arguments. It's always a good idea to improve code. So go ahead and do a small refactor to clean up some bits. It's best we keep the symmetry of the existing code. So we follow the same pattern as we did for arithmetic expressions. This allows someone to read the code quickly, and also it is easier to see if a pattern emerges, which can be abstracted away. So in order for us to handle Boolean operations, we have to extend the atom type union with the Boolean type. But this means we have to check for the type each time before we use it. I think we can do better. One of the great things about TypeScript is having generics. let's make a small change to the atom type signature to introduce generics. So we created a new type called AUT, which represents an atom that can have 3 data types as we have specified here. And we go ahead and fix the breakage to reflect the changes. Now, as you can see, we can simplify the code further because we don't have to validate the types before performing the operations. This is the result of having static typing as provided by TypeScript. So let's get on to actually creating the comparison operations. We can compare all 3 data types of atom, unlike arithmetic expressions, which are only for numbers. So here we are enforcing the types to assist the type checker. And then we extend with more comparison operators. success. So while we are here, let's implement the logical operations as well. You can see how easy it is to extend the parser with various operators now. It is the same pattern repeated as before. It is great to see that many mistakes are captured by the type system as well as the unit tests. And now for the icing on the cake, conditional operations. This, as you see, is a simple change, just like before. And now we harden it with more tests. Now our Lisp interpreter is able to perform arithmetic, logical, and conditional operations. In the next video, I will be extending this further so that we can define variables and functions and execute them. Join me then.